Well, let me start this just by saying why we get these complex answers. You and I have talked about this for a little bit already, but the idea is that if you have some graph and you're graphing it looks like this, and I ask you the question, how many, what's the solutions for when your graph hits my line? Our answer is that there are no solutions. And that's correct. There are no what we call real solutions. In other words, there is no way for you to obtain when your graph, this guy, hits this line. There are no real solutions. And the reason why no real solutions appear in that world, if you look at the example up here, when I ask you when does this graph equal this line, and what happens is when we take the square root of both sides, we get this issue with the square root of a negative number. And that's why up to this point you and I have always said no real answers. We just stop right there. But because we now have learned about what it means that we can take the square root of a negative number, and again, the way we approach that is if we get the square root of -3, we pull out the square root of 3, which we don't mind, and we pull out the -1 square root, and it simplifies to the square root of 3 times I, because I is exactly the square root of -1. And so this is how we operate. If you take a look up at the top again, you see how we basically then just work with it, kind of like a normal number. The other thing is that, as we mentioned previously, let me just clear a little bit of this out of the way, is that a complex number has two portions to it, an A and a BI. This part is like your real number, and this part is your imaginary. So, 3 minus 2i, or the square root of 5 minus the square root of 7i. Again, the first portion, this part is the real numbers that we're used to. That's what we're used to. And then we tack on the imaginary part so that we're able to solve this. So let's look at how, using two other techniques, which you already know, the quadratic formula and completing the square can be used to do this as well. Let's complete the square first. We do what we always do. We move the 40 to the other side, and I get -40 over here. Then I take half of 12 and square it and drop it into the spot, so we add 36 to both sides. And this is where a moment in time changes. We get x minus 6 all squared. That's normal. But over here we get -4. And the problem arises is that when this happened to us before, we bailed out because we didn't know how to handle the square root of -4. But now we do. What we're going to do, actually I'll do it in two steps. I'm going to do the square root of 4 times the square root of -1. So I get x minus 6 equals 2 times I. And then all I have left to do is move the 6 over, so I get 6. Oh, this should be plus or minus 2i. So I have two solutions, 6 plus 2i and 6 minus 2i. Now, again, we're back to that business of expecting two answers, aren't we? That's kind of an interesting thing happening, again, with quadratic. The key is this moment right here where I separate 4 from that -1, and then that allows me to keep the game moving here. Let's do one more. So this one, they want us to use the quadratic formula, which is on this guy. So the negative of -2 plus or minus b squared, -2 all squared, minus 4 times a times c all over 2 times a. So I get 2 plus or minus 4 minus 40. You can already see the problem arising. 2 plus or minus the square root of -36 all over 2. Now, it wasn't too long ago that we were naming that this meant no solutions. So you might be saying, wait a minute, you're about to tell me there are solutions. There were no real solutions, no real number solutions. But you and I now know how to solve this guy. This would become 2 plus or minus the square root of 36 times the square root of negative 1 over 2. Running out of space. 2 plus or minus 6i over 2. And then when I divide 2 into 2, I get 1. When I divide 2 into 6i, I get 3i. And there is my set of solutions. I is kind of a cool thing, to be honest with you. Once you get used to it, it's not that scary an item. So this will help you out.